দাঁড়াও তো তুমি। তো ঘুমাবোই, তারপর কি করবো? ক্লাস হোক তারপরে। তুমি না জ্ঞান না যে উঠেছি সেটাই দরবড়া, আবার তুমি কাজ করো। ক্লাস তো হোক তো তারপরে। আচ্ছা, পরে দেখা হবে। থাকুক না বাপ। যা করার আছে করো। সব ঢুকে বসে আছি, বোঝাবে এখন বাজছে। ক্লাস তো শুরু করে মনে না, শুধু এখন। এত ফালতু মাথা খারাপ করে না। উল্টে আমাদেরকে ইউটিউব দেখেই পড়তে হলে ক্লাসটা করার মানেটা কি হচ্ছে? এই ক্লাসের চক্করে করে সবাই পায় যায় পড়ার জন্য।
and f of a plus h, the product of these two is negative. And being of that, it is going to intersect with the x-axis. So therefore, there is one value of by the intermediate theorem that there is a one point on in between a and a plus h for which fx is equal to your 0. So therefore, we can approximate that value by your x0 by some process. So that approximation we are going to more tuned, and that tuning can be done by this process. That is also your one application. Now, we can also find out the, you may know, that is the increasing and decreasing of a function. So we solve one problem on that. Know this one. So we solve the problem. Find all critical values of the function fx x to the power 1 by 3 x minus 3 also find the minimum and maximum of f. Fx. Okay, over we have to define over some interval for which we could find it out, and we have to take a test of this. So you have this function. This function, you can see that it is your continuous, but if you're going to find out the derivative of this function, that f dash x, it comes to your, if we differentiate first this one, that will give you 2 by 3 x minus 3 to the power minus 1 by 3 x to the power 1 by 3 plus x 1 by 3 x to the power minus 2 by 3 x minus 3 to the power 2 by 3. So that ultimately in this form, better to write it down in this form, that is 2 by 3 x to the power 1 by 3 divided by to the power 1 by 3 1 by 3 x minus 3 to the 2 by 3 divided by x to the power 2 by 3. So that is your f dash x, and you could see that this function will not be exist, f dash x will not be exist for the point your x equals to 0 and x equals to 3. These are the 2 points for which it will not be exist. So f dash x exists for x not equals to 0 and x not equals to your 3. So what are the critical points? So critical points can be considered to be the terminal points. Critical points can be considered to be the points for which your f dash x equals to 0. Critical points can be considered to be for which the function is not being defined. So the points mainly, initially if we define, so the critical points where the function has its special feature, critical points, what it will be, that is your x equals to minus 1, x equals to 4, that is the end points of the interval, end points of interval, x equals to that you have to find out the point at which you have its f dash x equals to 0. If you find it out, f dash x equals to 0, so that is f dash x equals to 0 implies that this is 1 by 3, 2 by 3, okay, 2 by 3 x to the power 1 by 3. Equals to 0. So if we take that that is your this will come to 2 by 3, this one is x, and denominator we can take how we compute. That is x to the power 2 by 3 that is plus
Extending that minus 1 by 3 whole term right side, it will
So
be
x minus y divided by x to the power 2 by 3 into s minus 3 to the
yes.
power 1 by 3.
This is equal to this. That will also be given.
Right side.
Okay, I'm writing in this way. So to find out that the critical point, we have to make that numerator part equals to 0. That is your 3x minus 3 equals to 0. So that is 3x equals to 3 implies x equals to 1. That is a critical point. Now this is for to 0. So one type of point we are getting here, another point we are getting here, and the third one we can consider that the point where the function is not defined, that is x equals to 0,
আরে ফ্যাকাল্টি না পড়ে ওই
x
যে
equals
টিউটোরিয়াল
to
পিএইচডি
3,
ওর দিয়ে
where
পড়াচ্ছে
f dash does not exist. Does not exist. Now to find out the maximum, local maximum and minimum, as you know that we need to compute that f double dash, and then you have to check that which one is your less than 0, and then you can compute. So local maximum or minimum can be found, max or min can be computed at the functional value at each of this point. So these points. That I think you could be compute by yourself. Okay, we come to the next problem. So we consider the function what value find the relative maximum and relative minimum of f defined by fx equals to x plus 1 by x. Of course, this function is not being defined for your x equals to 0. So for x not equals to 0. So therefore x is not in the domain of your f. So solution we can be saying. So as you know, to find out your relative maximum to relative minimum, we have to check that f dash, the characteristics of your f dash or the change of your f dash, that is f dash is your suppose from greater than 2 changes to f dash less than 0 over an interval. We are breaking at some point. Suppose you have that interval from your x1 to or x0 to x1, x0 to x1, then in between which you, if you have a point C, then from your x0 to C, you have that the f dash is your positive and C to x1 is your negative. Then we can say that at the point C the function has its maximum. If the reverse thing will happen, that is f dash is your less than 0 in between your x0 to C, and f dash is your greater than 0 in between C to x1, then we can have it has its your minimum, local minimum. So by that criteria we just verify this one. So if you have f dash x, its derivative is your 1 minus 1 by x square, and this function will also not be exist for your x equals to 0. So we have x square minus 1 by x square not being defined for x equals to 0. So if x has no critical value for x equals to 0, we are not considering in this case, because f dash x is not being exist. So what are the critical values? So critical values are
Plus and minus 1.
yes,
1 and minus 1.
critical values are x equals to plus minus 1. So at those points we will consider, but for that we have to consider one interval that will contains of these two. So if you draw this, the graph will separated by this line. It has its region something like this. The curve is that you have this. So for the point your minus 1, if you consider that is your minus 1, then this one is considered to be minus 2, and we are considering that is your 0. Not touched. Very close to 0. So this is the interval we are going to consider, over which your minus 2 to 0, and we consider the point your minus 1, which contains the point minus 1. Another side we are considering the point is your the graph is, we could not consider that x equals to 0, so we have to exclude that point, of course. We have to exclude this part. Okay, so and again from 0 to 2, in between which will consider your f of a, if 1. So f dash, if you are going to test in between your f dash x is, you can find it to be your positive in between your, for all x in your minus 2 to minus 1. It's going increasing towards your minus, up to your minus 1. And f dash x, you can find it to be negative for all x in your minus 1 to 0. Okay, so therefore f of minus 1 means x equals to minus 1, the function has its relative maximum. F has its relative maximum, and that is your f of minus 1 that you can compute very easily, which is minus 1 and minus 1, that is minus 2. Similarly, if you consider that the from 0 to 2, so f dashed x is your negative between this interval for all x in open interval 0 1, and f dash x goes to positive for all x in your 1 to 2. So therefore we can say that the function has its relative minimum. So therefore f has its relative minimum at x equals to 1, and the value is your f of 2. F of 1 equals to your 2. So this is the function where we are getting that the relative maximum is your less than that of the relative minimum. If you are going to find out all the points at which you have the relative maximum and minimum, so we solve one problem more. Third one, you consider the function that f of x equals to
Sir,
x. Yes.
in the previous questions, sir, why we consider the interval between minus 2 to 2?
we can consider any interval, but only if you consider the interval something like your from -1 to -3, so you could not be find it out because it comes to something like that. The curve will goes out like this way. We have the problem at the point x equals to 0 where the function is not being defined. So that means somewhere we are getting stuck, means there is a change will occur around the point x equals to 0. So that's why we are considering here from -2 to 0 and then after open interval 0 to 2.
Sir, can we consider it from -3 to 0?
-3 to 0 you can consider, but there will be no change. You will get it. Only the change will occur at the point -1.
Yes, sir. Yes, sir.
X minus 1 whole 3, x minus 3.
And sir, it is necessary that this type of question we can only be solved by graph. We cannot do it
No,
by
no, you no
one
need to be,
equation.
you need no
আমি
need to be
শুনতে তো
solved by
পাচ্ছি না
graph.
দিদি।
Just to associate this one, I am showing you. You can consider anything, but because we know that the function is, you can find out the derivative. Now you find out the value f dash x,
Sir,
whether it is for all values of.
with double derivative also we can find, sir.
It is same as double derivative. Na. If
Huh,
f
you
dash
can
Yes,
x
also.
sir.
is changing from sign
With the double
minus
derivative also the same answer
negative to negative. Yes.
comes.
Yeah, definitely.
Yes. Determine all. Relative maximum and minimum. So in this case, we are not drawing any graph. We are going to solve. You have the function fx. It's very easy to find out the derivative. We can do the derivative. F dash x, that is 3 into x minus 1 square, x minus 3 plus that x minus 3 is 1, that is x minus 1 cube plus 1 is 0. You can simplify by taking your x minus 1 square, it is x minus 1 square, give you 3x minus 9, 3x minus 9, that is plus x minus 1. That comes to your x minus 1 square. 3x minus 4x plus minus 10. So 4x minus 10 we can take common 2, of course. It is 2x minus 5. 2x minus 5. Now this one is exist for all values of x. So this exists for all x. We have not to exclude any point. Now what are the critical points? So f dash x equals to 0, that gives you, of course, your x equals to 1 and x equals to 5 by 2. So the critical points are x equals to 1 and x equals to 5 by 2. Now you can see the changes what you have in between your x equals to 1 and x equals to 5 by 2. So we can have that f dash x, that the expression that you have, which is your 2 into x minus 1 square into x minus 3, I think so. Oh, no, 2x minus 5. 2x minus 5. 2x minus 5 is this. So this portion will never be negative because x minus 1 square. So only the negativity will come up until unless you reach it up to your x equals to 5 by 2. So therefore for your x less than 1, for x your less than 1, or if we consider that 1 less than x less than 5 by 2, what is happening? If your x is less than 1, that is half, then we can have the negative. If we have 1 more than, that is 2, that is 4, then it gives you negative. But 5 by 2, between 2 and 5 by 2, okay, it will give you also the negative. So between these two interval, you are getting that f dash x is your less than 0. Now for the remaining portion, that is if your x is greater than 5 by 2, then you have that f dash is your x is greater than 0. So from negative to positive, if we make changes, then you must have that the relative minimum. So therefore f have its relative minimum, and we are making changes here about the point your 5 by 2. So therefore relative minimum at x equals to 5 by 2, and that we could be compute, that is f of 5 by 2, it can be compute, that is equals to something minus 11 by 6, something like that. Just putting the values there. So that thing is that here you don't have the relative maximum, because the function is not look like that. Now if you see the graph of this function without computing, without your graph,
Sir,
see that,
please show
yeah,
previous slide once.
this one.
No, previous one. Yes, sir.
Okay.
Sir, why you have taken 2x minus 5? It is 4x minus 8, I think.
4x minus 8, so we have to make it change then.
No, sir, minus 1. 4x minus 10, sir. Then 2
Yes, sir,
common.
4x
That
minus
is your 9
It is
minus
correct,
9 and minus 1.
is right.
Okay.
Okay, sir.
Okay. So whatever be that, if you have it is your 4x 2x minus 8 is also, then you have to check accordingly that which point you are getting, for which you are negative or positive. That thing you need to be make change. The changes you need to be compute, so that you can say with what it would be. Okay. So this time you have no maximum. So what I'm saying that if you see the graph,
Sir,
such type of graphs is not being easy. Yes, yeah.
Sir, these relative maximum and relative minimum points only occur on critical points, or may occur any points other than the critical points?
No, these are occurring the critical points.
So why such, sir?
You're computing the maximum and minimum. So if you are going to see that, I do not know that the maximum and minimum, why this is called the relative, that you can ask, because with respect to the other points, the functional values that you have over an interval, if you are computing, this is also sometimes called the local maximum and local minimum, because over an interval, whenever you are going to compute with respect to the other points, we are saying that at that particular point you have the maximum value of that function. Okay. Now if you have, suppose the graph is look like this, if you see the graph is look like this, then how could you say that at this point you can have the minimum value? Because you can see that this is the point, this terminal is the point over this interval from this point A to the point, if we consider here that B. So from A to B you have this one is your minimum point, minimum value of that function. It is not being possible for this point. So what you have to do, at some point you need to compute that f dash c equals to 0. Then you have to check that whether the tangent value, means the gradient of the tangent, is your changing from your acute to obtuse, that is the angle we are making with the x-axis, that is acute to obtuse, then it comes to your maximum. If it is from obtuse to acute, then it comes to your minimum. So if you see the graph that we have drawn there, we have the maximum at this point. So here the tangent, if you draw, that makes an angle with the positive direction of x-axis, which is your acute. And the tangent at this point, if you draw with the positive direction of x-axis, that is an obtuse angle. So from acute to obtuse, because that is your positive to negative, it comes to f dash c is your positive to negative. So that time you are getting the maximum value. And if you consider the graph something like this, then if you draw the tangent, because we are coming from this side towards this side, so if you draw the tangent, then it will give you first the obtuse angle to acute angle. So that changes the sign of your derivative of the function at that point. So that changes gives you the minimum value. Okay, and that comes to the idea of your Lagrange's mean value theorem, which is your also define the function is your increasing or decreasing type. Okay, so that's why we are going to actually breaking the interval between that point about the critical point. Okay, suppose the graph is your flat, then it has no critical point. How could you find it out, that critical point? Okay, so
Yes,
only the values can be obtained for your critical points.
and sir,
Okay.
relative maximum and local maximum, are they always similar? Means, are they always same?
Yes.
Okay, sir.
Okay, some student has said me to solve the problems given by SAR. So I cannot find those problems where I have written that problem is.
Sir,
Yes.
sir, in this question, one is also a critical point, but why we don't consider that? Find out the minimum value.
Why? Because you can consider that for 1 you are not getting anything. If you put that 1, I have said that x minus 1 will always be your positive. It will not be make any changes. If you are considering that x, yes, and that is actually called the point of inflection.
Sir, so what is meant by Gaussian integral?
Gaussian integral. In which connection you are saying this one?
Sir, last day we did a sum which
Ah.
was integral of minus infinity to infinity e to the power minus x squared dx. So that
Minus
time
infinity to
sir
okay,
said the word
yeah.
Gaussian integral.
Minus infinity to plus infinity e to the x into e to the power minus x
Power?
squared dx.
No, sir. E to
Yes,
the
sir.
power minus x square dx.
See, only e to the power minus x squared dx.
Yes, sir.
Okay. Okay. So that integral may be deduced by Gauss. That's why it is called your Gaussian integral. It's actually called also the error function, I think. From 0 to infinity e to the power minus x squared dx. I could not recall all the names. It's not being possible. But
Sir,
if you
why
have
is
any
it called
difficulty
error?
with this problem, name is given for
Yes, sir.
various reason. Name can be given for various reason. Then one has to go through the history why the names are given. I do not know what.
Oh, achha.
The problem
It's
do you have
only
with that problem?
no, so there is no problem with doing the sum. I
Okay.
asked why it was named so.
Okay, then I have to go through the history. Okay, I do not know
Okay, sir,
exactly.
you can do it later.
Sir,
Yeah.
what is the main difference between iterated and integral? Means
Main difference between?
iterated integral and double integral or triple integral, something.
I do not know who is asking this question. Why don't you ask to the LKT sir?
Sir, he did not give that much time. He says you should ask in tutorial class.
No, he never says
Yes,
like
sir.
this one.
Yes, sir. Yes, sir. This is only he said.
Yes, sir.
Our mic actually, we don't understand that iterative
Sir, he's
integral.
taking class for 860 students, so he cannot solve doubt
Sir,
of everyone.
he mute all of them and then we will not ask them.
Yes, sir. We are not allowed to
Okay,
ask.
so
Sir told us to ask you.
so the double integration
Just
is
give
what?
some
Double
clarity.
integration, we are computing the volume. What I have said you that the volume Okay, over a double integration, it can possible that for a double integration may not be your exist, but your iterative integral may exist. But the thing
What
is
is
going
iterated
on.
integral?
Okay,
Sir,
what
he
is,
said in
you can
triple
see that.
integral, 6 iterated integral means he says like that. In triple integral, it is 6 iterated integral means
In triple
is
integral,
it different
6
iterated integral? He says like that.
iterated
Sir,
integral. What you want?
he
You
is
want the
saying triple
difference?
integral have 6 types of iterated integral. How? I think so.
Okay, he asking that 6
We are
different
not
type of
getting the
iterated
difference between
integral.
integral and iterated integral. Present in triple integral.
In case of your triple integral. Okay, in case of your triple integral, we are getting 6 different type of iterated integral. Then which one we will solve and what the difference between them? Each of has its different orientation. If you consider first the first, it's better to understand this one if you really be are in queries. So you consider this double integration. If you could know that the double integration, then you could know the third triple integration, or if you have that 4 integrations, how many order of integrations will be there, it will not be problem. So you consider this is your x-axis and this is your y-axis. So then what we will do, we have to find out the double integration over, suppose, the basement, something like this, a triangle. For simplicity, we are considering this. Then what we will do, we just make a small strip of this, means equal division of this portion. It's not exactly equal, but just consider this one. Then we consider this cell all. So now we are going to compute in case of your double integration, I am saying. So what we compute, each of these square that you are getting here are you of your same, what is called are of your same area. Okay. So if you consider the smaller portion inside of this small same area is of your dx and dy. So that will give you the area, that is dx and dy you are writing. So you are writing dx and dy or dy dx. It's not the matter. Matter is now after considering this square, along which way you are going to move.
Sir,
Yes. Yes.
answer is 2/3, sir.
For which one? The problem I have written.
Yes, sir.
So that's very
Yes, sir.
good. So
2 by
some of
3.
your friends are saying that they are not being able to understand. So tell your friends. Okay. That answer is 2 by 3. I do not know that these problems are given by sir and he is asking me to solve. So I have said him to solve only 1 and 2 by the time permit. Okay. Okay. So what we are discussing is that that's a small portion you have. Then we are moving this strip, this small area, either along your y-axis or along your x-axis. So depending on that, the limits will come up. Okay. Now if you consider the z-axis, then what will happen, the surface we will consider here in that. You can have the surface something like this, surface something like this. Okay. Now you can join this. This is the surface. That portion is being bounded. So this is the upper surface. So you are going to find out the volume of such thing. Okay, that we are computing in case of your double integration. So if you are going to directly evaluate the double integration, sometimes it may possible that the curve will not be defined. Okay, the double integration will not be exist. Just for simplicity, if you think of for function of several variable, you have the limit, that is limit as xy tends to some point a b, besides that's f of xy. Whenever you are going to whenever you are going to move evaluate this integration, you have to test that the limit exists or not. Then you could not be moved from your by your own way, that x will tends towards a separately and y tends to b separately. You have to move the point xy towards AB as a whole, as means together. So for that you have to choose one path so that x and y moves towards AB along with. So that path you are considering, that may be your some point, means some function, that is what will I say, that the path we can consider. So that will also be give you a function of your x, y, a, b, phi of x, y, a, b. It ultimately gives you a function. Okay. So now we replace those values of your x in terms of your y in terms of your x. Then we just find out that the value of this limit is your path dependent or path independent. Now depending on that, we can say if it is path independent, then we can say that the limit exists, and what is the value we are getting, that is your the value of the limit. But if you are going to evaluate this integration, this limit by your repeated limit, that is different limit, x tends to a and limit y tends to b, then f of xy. That time we are considering what? That time we are considering that as y tends to b, we supposed to be that x is your fixed. Okay. So whenever you are considering that y tends to b, we consider that x is fixed, and because of that x is fixed, you just evaluate this one as of your single variable limit. Okay. So that's why I have given you the initial, so that is your repeated integral, repeated limit evaluation. Okay. So because of this clarification, I have given you initially that the figure, what we are doing here, if you consider the curve that is most useful. So we consider a path on this surface. Then on this, we consider this one is your y, this one is your x, this one is your z. That is the volume, the height will give you that. So if you fix on x for some point on your x, then we can consider one curve in your on your surface, and then area under the curve will give you the area of this portion. Okay, so we are computing for the limit of your y, that you are saying something, some function may be the limit, or your the some function that is phi 1 x to phi 2 x, and the function is of your f of xy dy. That's the integration, area under the curve bounded by these two surface curve and this following line. Then we just move this strip from which point? Suppose this is the point of your the origin is somewhere else, herein that the origin, but this is the point your x equals to some bounded by some curve, can consider, or this portion is your bounded
ওটাই তো
by
আছে,
some
এবার
curve,
শুনতে পাচ্ছি।
or maybe some value. So that gives you the range for your x. So range for your x will given or defined by, for x equals to some constant your k1 to x equals to some constant k2. So since you are integrating with respect to x, so then dx will come up. That is the repeated integral. But if you consider the overall, what you say, the double integral, then you have to think of like this way. Then we moves this rectangle or the square along the side as a whole. Okay, by considering the path, whichever you will consider. Okay, so these are the two processes. Now to evaluate that of your double integration, is it? I do not know that how much I can clear, because you are asking from the very beginning, and I supposed to be that it has been clear to you, and you are asking whatever be that. Okay, so
Sir, what is meant by changing the order of an integral?
Wait, changing the order of an integral is your something like that. Sometimes we could not be able to find out the evaluate the integration. I think we have solved one problem in the last class also. that it is hard to calculate the integration with respect to y first and then the with respect to x. Okay, we could not be move on that someone says that every time we have to draw the graph, it is not being possible. So what we have to do, we have to change the order so that we could integrate the function, then we can find out the value. Okay, that you are taking initially that the strip along your x-axis. For changing the order means we are integrating with respect to x first, so we are taking the strips along your y-axis, parallel to y-axis. Okay, thank you. I have another assignment.
Thank you, sir.
Thank you all.
Have a nice day, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir, इस क्वेश्चन
Thank
का
you,
आंसर
sir.
2/3 है.
कितना था आंसर भाई?
हेलो हेलो
मेरा तो 1/3 आ रहा है.
2/3 आ रहा है.
क्लास खत्म.
2/3 आ रहा है भाई.
मेरा भी 2/3 आ रहा है भाई.
ये भी वो लिमिट
हेलो
चेंज
भाई
करके करना पड़ेगा तब इजी होगा ये क्वेश्चन.
क्लास खत्म है क्या?
खत्म.
हाँ भाई.
अगली क्लास कब से भाई? अगली क्लास